Assalamualaikum and hi everyone. So today our group is going to present experiment 2 linear motion. Before that, let us introduce ourselves first. I am Athirah.
My name is TISYA.
And I am AMANY.
The objective of this experiment is to use linear air track to investigate Newton's second law of motion.
Theory. Newton's equation of motion for a point of mass m to which a force F is applied is given by the formula F equals to ma. When m2 is released, both objects will accelerate due to their massless connection. An analysis of the system's motion assuming Newton's law of motion is provided.
The first figure demonstrates three forces acting on M2, including the frictionless surface contact force T, normal force, and gravitational force, which cancel each other, resulting in zero total force along the vertical direction on M2, leaving tension in the string as the total force. Newton's second law said that M2 will accelerate and give the equation T equals to M2A.
The figure reveals that M1 is subjected to only two forces, gravitational force in the downward direction and the tension that pulls it upward. By using Newton's second law, F total equals to T minus M1G equals to negative M1A. Eliminating T from equation by substituting equation 2 into equation 3, a single equation for the acceleration is written as M2A minus M1G equals to negative M1A.
Newton's second law states that a system of mass m2 plus m1 with net force equals to a straight line with a slope equals to its mass. If the mass of m1 is varied, the gravitational force and acceleration system are considered. Tension is eliminated from the final equation as it's only concerned with system forces. Acceleration, A, can be determined by using equation x equals to ut plus 1 over 2 at square.
If the glider starting from the rest moves at distance x meters along the air track in time t seconds, the acceleration of the glider can be found from x equal to half a t squared or a equals to 2x per t squared. Substituting equation 1 into equation 6 gives x equal to half f per m t squared.
The apparatus needed for this experiment is a tread rail, blower, pressure tube, gliders, flag, photo gates, masses, mass hanger, string, and pulley.
Procedure. First, the linear air track was assembled as shown in figure. Second, the air should be allowed to blow through the track several minutes with the pump switched on, and the track should be balanced by having the screws on the legs of the track adjusted so that the glider stays stationary and does not glide to either end when let go. Third, one hook was inserted at one end and a flag was placed on top of the glider. Fourth, the mass of the hanger and the length of the flag were measured and recorded. Fifth, the one end of the string was attached to the hanger and the other end to the glider. Sixth, the mass of 20 grams was placed on the hanger and the string was put over the pulley.
The glider was positioned exactly before the photo gate. The glider was released and the time shown on the photo gate was recorded. The step was repeated 2 times to obtain the time average values. Step 6 to 8 was repeated 4 more times with 20 grams each added to the hanger.
This is the result that we obtained from the experiment.
Analysis. First, plot a graph of weight force Fn versus acceleration A meter per second square.
Number 2, what does the graph tells us? From the plotted graph, weight force Fn that acting on an object is directly proportional to acceleration A m per s squared of the object. This can be shown based on how total force have affected the acceleration of the object.
Number 3. Do these results support Newton's second law? Newton's second law states that the acceleration of an object determined by two variables, which is the net force acting on the object and the mass of an object. The results of this experiment shows that the acceleration of the object is directly proportional to the weight force acting on it and inversely proportional to the mass of it. The acceleration in this experiment increases as the weight force of the object increases, thus supporting the Newton's second law.
Fourth, discuss any sources of error. In this experiment, some errors may occur since it's conducted in a laboratory room that have exposed to the air. For that reason, air resistance opposes the actual velocity, causing the applied force can be slightly more or vice versa than the force acquired.
Conclusion: the net force upon an item is similar to the object's mass times its acceleration. Additionally, it plays a part in determining out how the net force on an item and its acceleration are related to one another. Newton's second law of motion states that an object's velocity and acceleration can be modified by varying the force acting on it.
That's all from us. Thank you.